Alrighty, our second video here is going to show us how to balance our chemical equations. Alright, so sometimes these skeletal equations are already balanced and other times they're not balanced. And the way that you do that is by taking inventory. You ever take inventory for your job? You count up what's there and you see how much of everything you have. So you can see I have one carbon on the left, one carbon on the right, and we have to obey the law of conservation of mass and matter. I have two oxygens on the left and two oxygens on the right of the yield sign. So that checks out, and this one is already balanced. But if I have C plus O2 makes CO, carbon monoxide, I have one carbon on the left, one carbon on the right, that checks out. But I have two oxygens on the left and only one oxygen on the right, and that doesn't check out. So this is not balanced. So what do I do then? Okay, please star circle highlight these rules right here. These are a great guide to making sure that you balance out all your equations correctly. So first things first, you always write that inventory, okay? Sometimes you're going to start off by actually making a physical inventory list, and eventually you'll be able to do it, just by looking at the equation. You balance everything that's not a hydrogen or oxygen first. Hydrogen and oxygen are very common elements, so the other elements that are more rare are going to kind of dictate how many hydrogens and oxygens you have on each side. So how do you balance it? You add a coefficient. Remember, the coefficient is the number out in front. You are never going to change this subscript here. Okay, the subscript is that little number here that changes the actual identity. You are only changing it by writing an actual number right there. When you do that, it retallies because this 3 distributes behind everything behind it. Okay, so you have to adjust your inventory as you go. Then make sure if you have other non-hydrogens and oxygens, you do them next. Then we're going to do our hydrogens next and keep our oxygens for last, doing the same coefficient adjustment. And at the end, you recheck your inventory to make sure that you didn't mess up anywhere. Okay, so what I suggest you do is you have two different color pens, a pencil and a pen, or a colored pencil, a marker, something like that. And what we're going to do is we are going to do our inventory. So we'll start off with one of the simplest equations first. H2 plus O2 gives us H2O, making water. All right, underneath the yield sign, you want to make an almost tic-tac-toe board. All right, we have hydrogen on the left and hydrogen on the right. So underneath the yield sign, I'm going to put hydrogen. On the left, we have oxygen. On the right, we have oxygen. So I'm going to put it over here. So this is my tally for this side of the equation, and this is my tally for the product side of the equation. Some people do H and O on this side and H and O on this side, and I personally think that's double the writing. If it's the same thing on each side, just leave the same thing in the middle and only count up this way. So that's a little tip from my chemistry teacher, Mr. Ray, back in the day. All right, so here is H2. So that means I have two hydrogens on the left and O2, meaning I have two oxygens on the left. On the right-hand side, I have two H's and I have an implied one oxygen. Now switch your colors. All right, and when you switch your colors, this is the color that you're going to use for your coefficient. All right, so balance all non-H's and O's first. Okay, I'm good. Balance your H's. I'm good there too. So now we balance the oxygens. Okay, so this side has 2, this side has 1. So on the side where you have less, you're going to put a coefficient out in front. I usually underline my coefficients so that looks like a 2 and not like a Z, so you don't get confused. And that distributes everything behind it. So it's going to change the number of hydrogens and the number of oxygens. I now have 2 times 2 hydrogens, or 4 hydrogens, and 2 times 1, or 2 hydrogens. That balanced my oxygens, but it unbalanced my hydrogens. And that's okay, because if you get thrown off balance, you just got to wobble a little bit. And when you wobble, then you fix your adjustments. So how do I balance my H's now? Now I come back up here, I put a 2 in front of the H2, and that changes this to 4. So I have 2H2 plus O2 yields 2H2O. So double check. Okay, I have 4 hydrogens on each side. I have 2 oxygens on each side. That checks out. And I have your first a balanced equation. Yay! All right, so here you'll see your answer. 2H2 plus O2 gives us 2H2O. All right, now let's try something a little bit more tough. Okay, so go back to your first color. You have NaCl plus H2SO4 gives us Na2SO4 and HCl. You have the same elements on both sides, so under the yield sign, make your tally. Every capital letter is a new element. So I have Na, I have Cl, I have H, and then do you recognize SO4? SO4 is sulfate. If SO4 is a sulfate over here and SO4 is sulfate on the right-hand side, I can actually treat that polyatomic ion like an element. If not, you would split up your S and you would split up your O opposite. It'll work both ways, but it's up to you. Okay? Now, on the left-hand side, I have one Na, I have one Cl, I have 2 H's, and how many SO4s do I have? I have 1 sulfate. On the right-hand side, they're going to be in a different order. Remember, they're rearranged. So I have 2 NAs, I have 1 SO4, I have 1 H, and I have 1 Cl. Okay, switch your colors. Okay, balance non-H's and O's first. So I have Na, I have 1 on this side, 2 on this side. So I'm going to put a 2 out in front of this NaCl. That changes my Nas and my Cls. So that doubles them. Now balance any other non-H or O. All right, so let's balance out our chlorines. All right, I'm going to put a 2 out in front. No, you cannot put a 2 here. You have to put a 2 out in front. HCl2 does not exist. So that changes my H's and my Cl's. I now have double the amount. All right, balance everything else. Oh, wait, we're already good. I rechecked my inventory and it all checks out. So again, sometimes you balance one thing and it unbalances another, and that is okay. It's supposed to be that way. Okay? All right, last of these level 1 type problems for these examples. All right, so we have Fe plus O2 makes Fe2O3. Okay, we're going to make some rust. We have Fe and we have O. On the left side we have 1, on the left side we have 2, on the right side we have 2, and on the right side we have 3. Switch your colors. Okay, so Fe, there's 1 here, there's 2 here, so I'm going to put a 2 out in front like that. Great. Now my ions are all balanced. Okay, so now I have my oxygens. I have 2 here, I have 3 here. Well, if I double this side, I'm going to get 4, and 4 and 3 aren't double. If I double this side, I'm going to get 6, and 6 and 2 aren't double, so I have to find the common multiple between these. The common multiple between 2 and 3, the lowest common multiple, yep, 6. So sometimes, in order to balance, I have to do 2 things. I'm going to have 3 O2s to give me 6 oxygens on the left. And then I'm going to need to put a 2 out in front here and a 6 in front of this oxygen. But don't forget, it's going to change your ions also. So now this is a 4. Oh, man. Well, that's okay. Even if you already changed this, we can rechange it. Okay? You can change something that you have. And you can end up putting a 4 here and be balanced. So you have 4 on each side, and you're working out okay. All right, so here is our answer for Fe's plus 3 O2's give us 2 Fe2O3's. All right, so make sure that some nice little helpful hints. If you have that polyatomic ion exists as the same on each side of the yield sign, you don't have to split up the atoms. And if you have a diatomic element, you can have a half or a decimal coefficient, and I'll show you that in the next video. All right, so don't forget about our diatomic elements. They're not going away, just like our ions.